welcome to section 8.5. This is the last section in chapter 8 for us, and we're showing you one of the applications as to why we spent so much time using determinants yesterday. So what I want to do is take a second and figure out how to solve this intro question. And so they give you two equations. 2x minus 3y is -9, 2x plus y is 11. You may use graphing, you may use substitution, you may use elimination, you can even use Gaussian elimination if you'd like, but in some way you should have the work there when you come to class as to how you found the solutions. To save us a little bit of time, I'm going to tell you the solutions are 3, 5. But again, for your notes points, you should have how to solve that in any method of your choice. Okay, now here's what we're going to do. We're going to show you another way to find the system solutions by using matrices. And so we're going to do a 2x2 matrix with only the coefficients, and we're going to call that matrix D. Now this kind of comes back to Algebra 2. The coefficients are 2, -3, 2, 1. Okay, we're going to call that matrix D. And what we're going to do is find the determinant of it. And so if I find the determinant of a 2x2, we know that we do A times D minus B times C. And I'm changing the order there only because I didn't want to deal with negatives. 2 times 1 is 2 plus 6, so I get a value of 8 for my coefficient matrix. Okay, so the determinant of the coefficients is 8. All right, in the next one, and you know what, actually I'm going to slide this down a little bit a second so that we can kind of see all three. I'm going to do this again. The second one I want you to look at, and I want you to find the determinant of this new matrix, which we're going to call dx. Okay? And if I look at that, d sub x looks like this. We're going to take the determinant. And our coefficient matrix is what we're starting with, but we're going to replace the first column with the constants that were at the end. So my x column, instead of saying 2, 2 like it did before, it's now going to say -9, 11, because that's what it equaled. I'm going to leave my y values the same, -3, 1. And I'm going to do the same thing now before. I'm going to do the determinant. So -9 times 1 minus 11 times -3. So -9 plus 33 is 24. Okay? And I call that d sub x because we're replacing the x values with our constants. So let's try a different one. Do d sub y. And what that means is we're going to find the determinant of the matrix where the y values are now replaced with our constants. So the y's are -9 and 11. And the x's go back to the original constants of 2, 2. If I'm finding the determinant, 2 times 11 minus 2 times -9, so 22 plus 18 gets you 40. All right, now we told you the solutions in the intro were the values of 3 and 5. So x is 3, y is 5. Our question is, can you use these three values, d, d sub x, and d sub y, to find those solutions? Now, if you look at it, I could find x by taking d sub x and dividing it by d. I can find y by taking d sub y and dividing it by d as well. And if you look, 24 divided by 8 is the value of 3, and 40 divided by 8 is the value of 5, which was our y values. And so this is another way of finding solutions, is by using, it's called Cramer's rule. And so it's this idea that you can divide determinants in order to find solutions. Now, let me be honest, on the test, you will have to do a 2x2 using Cramer's rule. So kind of be aware of that as we go through. So let's kind of go down to the bottom. We're going to show you something a little bit bigger. And again, in order to find the solutions, Cramer rule says take d sub x divided by d. In order to find y, take d sub y divided by d. In order to find z, take d sub z divided by d. And again, the number of variables, you keep going up, you get this More solutions, the more variables you get. Okay, so let us show you a 3 by 3. In this 3 by 3, we're going to use our calculator just to save time. So use your calculator. Okay, only to save time. Now, here's what we're going to do. We said the normal D was if I take the determinant of just the coefficients. So my coefficients are -1, 2, -3. My second equation is 2, 0, 1. Let's just erase this and try that again. And 3, -4, 4. And what I'm going to do is put this matrix in my calculator, and then I'm going to hit the determinant button to figure out the determinant. And we did this yesterday in class, so the determinant for this matrix is 8. Okay? I'm going to do D sub x, and so I'm going to do the determinant of a different 3 by 3, only I'm replacing, because I'm doing my x's, I'm replacing my x values with my constants, 1, 0, 2. Okay, so 1, 0, 2 gets replaced. The rest of them stay the same. 2, 0, -4 going down, -3, 1, and 4. And if I find this determinant in my calculator, so you just keep going back and forth and switching it, I find that this determinant for D sub x, I'm sorry, this one is 8. So let me change this a second. The determinant is 10 for the original coefficients. Can't even read my own work, I'm sorry. All right, let's do D sub y. D sub y means replace the y column. So the second column, 1, 0, 2, is now our coefficients for y. And we go back to our normal D and put in those for x and those for z. And if I find the determinant on that, D sub y ends up getting to be -15. Last one, replace z. So 1, 0, 2 goes in z. -1, 2, 3 is the x's. 2, 0, 4 is the y's. What I end up finding for the determinant of z is you get -16. Now, this is really easy to do when you just use your calculator, because your calculator finds the determinant for you. If you had to do this by hand, we'd talk about picking a row and a column again, and I can see some of these. I'd pick this row, I'd pick this row, maybe I'd pick this row, I'd probably pick this row, and so you can kind of see how more difficult it would be, because you'd have to do 4 minors and cofactors and things like that. So it would take a little bit more work by hand. Now, if I want to find the value of x, I take D sub x and divide it by D. Well, D sub x we said was 8. D is 10, so 8/10 reduces to 4/5. To get y, I take D sub y divided by D. D sub y is -15 divided by 10. Divide each by 5, you get -3/2. In order to get z, D sub z divided by D is -16 divided by 10. Divide each of them by 2, you get -8/5. And so here's your solution. And again, if you write them as like an ordered triple, like we did earlier, you get 4/5, -3/2, -8/5. Now let's talk about why in the world I'd like to use Cramer's rule instead of Gauss-Jordan elimination. Well, as I'm looking at this, look at, I'm going to end with fractions, which means along the way I'm going to be dealing with fractions in my elimination, and this is way nicer to do with determinants than it would be to do Gauss-Jordan elimination. And so kind of keep that in mind as you're going through. There are times when it is beneficial. This obviously is one of them because you'd end with a fraction answer. So that's one application that we use determinants for. Again, it's called Cramer's rule. The second thing that we use determinants for is to find the area of a triangle. And so what we do, they're gonna give you a formula. You will have to know this formula. What it looks like is plus or minus 1/2. And I'm just going to write a single bar because a single bar means determinant. The determinant of, and in order to make this be able to find a determinant, I need a square matrix. But I only have 2 parts to a point. So what I'm going to do is put x1, y1, end with a 1. x2, y2 end with a 1, x3, y3 end with a 1. And this is a way of finding the area of a triangle without actually having to find distances, but using the distance formula or Pythagorean theorem or sines, cosines, tangents, whatever else it may be. But what you're doing, again, don't forget these bars basically mean find the determinant. Okay, so we're going to give you a look at how that works. If I'm trying to find the area of a triangle, I say plus or minus 1/2, and I have the points 0, 0, 1, 5, 0, 1, 0, 8, 1. Okay, now you get to pick your row and your column. Oh, I don't want to make that an actual matrix, I want to make that a single line for a determinant. Okay, now, if I look at this, I'm going to use, you can use your calculator, but I would actually try on your own doing minors and cofactors. And I would personally use this row because you have 2 zeros, so I only need the cofactor for this one. And if we do this real quick, I'd cross off row 1 and column 1. And in order to find the determinant, let me do a side note, I would take 1 times whatever the cofactor for 1, 3 is. The rest of them I don't really need because they're just zeros. So if I cross off row 1 and column 3, 5 times 8 is 40, minus 0 is 40, so that determinant is 40. So if I look at plus or minus 1/2 times 40, my question is the plus and minus, why is it there? Well, area can't be negative, so if your determinant is negative, you need to keep the negative to turn it to a positive. If the determinant is already positive, you keep the positive because, again, you don't want your area to be negative. Well, 1/2 times 40 is 20. Give it a label, square units. Okay? And so this is one way, again, of using a determinant to find the area of a triangle. Calculator-based, this eliminates so much work for us on a calculator, you know, in a picture form, because I don't have to find side lengths and angles and things like that. If it's by hand, you really hope that you kind of have some nice zeros in there that you can help eliminate. Last one is to test if points are collinear. Collinear means that the points lie on the same line. And the way we know that is if the determinant of this matrix, x1, y1, 1, x2, y2, 1, and x3, y3, 1, if this determinant is 0, then the points are collinear, okay? So if you're doing your determinant already for an area, you should be able to tell me automatically there would be no area because they're collinear, things like that. So if we look, let's find the determinant. Negative 2, 3, 1, 3, 5, 1, 8, 8, 1. And I'm going to use my calculator in this one to find the determinant, and when I do, I get 5. What that means are these points are not collinear. Okay, if only it's collinear if you got 0. Now what I'm going to do is I'm going to actually save the cryptology stuff for us to do in class, just to save us a little bit of time on the video. If you want to look into it more so that you can start your homework, take a look in your book, and they walk you through some of that stuff too, but I'm going to actually show it to you in class. So that's the end of this video. Thanks for watching 8.5. Again, we'll hit cryptography, in our class tomorrow.